Today's topic is about practices and patterns we should follow. But even the JDK doesn't or didn't follow them throughout the time. And what I want to tell you throughout the talk is, of course, not only some practices and patterns that you should follow, but maybe you will see that they are not followed throughout old code, but that even the languages libraries and even the most used libraries, and now I discuss about the JDK, but it could have been Spring Framework. You find examples within Spring Framework. It could have been Quarkus, it could have been Micronaut, it could have been, name any library of the Java language. And you will find out that throughout these libraries, you can find anti-patterns. So whenever you use a library, if something looks like it's not all right, throughout Hibernate, for example, take a look. You will find plenty of them. If you take a look throughout a library and you see something that doesn't look right, don't take it like, I don't know what's good and what's wrong, and the library is always right. Take it as, I have to research this. It might not indeed be right, and it might be something that even I can change if this is about an open source library, because especially with the Java ecosystem, many of the things are open source and you yourself can upgrade them, can enhance them, can augment them by changing the code, raising a PR in the project, and your code might even go there and enhance the ecosystem with a few lines of code. Imagine what would happen if throughout this all amazing community, we would have every one of us contributing with at least a couple of lines of code throughout the whole world. It would be amazing, no? You can do things to be better in your ecosystem, in the ecosystem you're using. And again, Java is not a language that has ever been perfect. It's not perfect now, it hasn't been perfect, and I can prove you. This is one of the first examples that shocked me. The date class, I'm putting it here because it shocked me like many years ago, okay? I know we don't use the date class from Java util anymore, and neither it's rewritten Gregorian calendar, but I will give you an example from my past. Take date, and then date get date. Who knows what this method actually do? Who can tell us? What does date get date? Somebody says the current date. Other options? Okay. Well, it actually gives you the day of the month. Ah, okay. So let's take another example. We have a get day. What do you think get day does? Day of the week, okay, that was fine. But do you agree with me that neither of these methods, if you see them for the first time, will they tell you actually really quick what they do? So are they patterns to be followed? These are just namings. It's a very simple code smell. You all might already know about it because now people and developers are a lot more aware about code smells, anti-patterns, design patterns, and so on. But do you agree with me? They are indeed good examples of code smells. And we can continue. Then the date was actually enhanced by Gregorian calendar, and then we have the Java time. Look at that date there. Can you tell me what date is that? 20 February 2024. Is that right? Well, it's March actually, yeah, because the month starts from 0. Why does it start from 0? I know, because we start from 0, because vectors are starting from 0, because I have no idea, but then why doesn't the day of the week start from 0? Why is that Monday? Okay? So, and you say, okay, come on, he's talking about date and Gregorian calendar, Java 8 already solved that. I mean, can it be that Java is that bad? It's just a couple of examples there. And then you start thinking about it, and you find more. Ah! Okay, guys, I'm Laurentiu. Most of you who know me might know me about my Java YouTube channel or some of the books I've written. I brought some of them with me to give them today. In case you want to follow me on social media. And now we're going to discuss more about different anti-patterns and things we should consider when using the Java language, but things that you might even see throughout the bare library of the language. And what we'll discuss is that not everything that is in the JDK is necessarily a good example, and I want to extend that. Not everything that is part of a library itself, even if it's really well known, it's a good example. I want to discuss why those parts have been implemented like that, why are they there, and will they be maybe rewritten in the future? And then, of course, I want to ask you and learn from you, how would you change these parts if they were your responsibility? So let's discuss about all this. And I want to start with one of the details that make Java a unique language, and not necessarily from a good perspective. It's these checked exceptions. I guess you know checked exceptions. You've used them, no? If you've used Java, you've seen checked exceptions. Have you implemented your own? Who implemented their own checked exception? A few, okay. Who prefers runtime exceptions? Who knows why interrupted exception and SQLException are checked exceptions? No? No one? Neither I do, sorry. They should have been runtime exceptions from the very beginning. But they are checked exceptions. Because the checked exception itself, as a concept, has been implemented at the very beginning of the language with a purpose that is no longer the purpose of the checked exception. And now you find it, and at least in these two places that tend to be very bothering, which is the interrupted exception, which is that exception that happens when a thread gets interrupted while it's in a block state, and SQLException. And if you have ever seen old code, and I really hope that you haven't, but I have the feeling that many of you have seen, even plain JDBC code, you will see that in many cases, developers simply just treated the SQLException and then they do nothing, or they simply log the exception in the catch block. Have you seen that? Okay, it's not only me. Why are you so shy? You can raise your hands. I want to see them, okay? Don't be worried. Nobody will be judging you, okay? We've all been through that. And I want to point out, okay, if this is not okay, then who wants to explain it? Because I told you, you will be the one telling me how should we solve this normally. I mean, not how can you now make interrupted exception not be a checked exception, because you can't do that, no? But let's see, it's your code. When would you use a checked exception and when would you use a runtime exception? For example, in this case, using checked exceptions, it's a clear example of introducing verbosity. Not that Java is not verbose as a language anyway, no? You introduce a little bit more verbosity, even more verbosity, and create a lot of frustration because you have to treat an exception, you have even no idea how to treat it. I have to treat the semaphore acquire method. What happens if staying in the acquired, my thread gets interrupted? How should I treat that? I have no idea in most of the cases. So let's say you have to decide, and you need to use either a checked exception or a runtime exception. What do you use and when? Who wants to tell me? Come on, guys, it's you. You are the ones here who needs to be active, not me. So, you've said you implemented checked exceptions and runtime exceptions. Maybe you want to give us some example. Don't be shy. I don't see any hand. Oh, we have a hand there. Yes. So let me see if I got it, so I can repeat it for everyone. You would implement a checked exception when you have an API, okay? Okay, but the question is, when do you want that? I mean, okay, checked exception forces you to treat the exception, and you don't want the application to have the exception at runtime, but when do you exactly want that? That's the question. And let me tell you when you want that. You want that only when you don't know how the method, how that specific method where the exception happens, it's called. That's when you want that. Because otherwise, if you know, you can already treat all the cases and the corner cases. Normally, you should think about them. You don't need to throw yourself an exception so you can treat it yourself. And then can you tell me when that happens? When does it happen that you don't know how one of your methods might be used? Exactly, when you use a dependency from the outside. So let's say you create a library. You create a library, someone will use your library. And you want to tell that someone that they should necessarily treat that specific exception of yours. Because if they don't treat it, it might occur during the runtime, and we don't want that, no? So that's the case. Otherwise, it doesn't make sense. And this is an example where it doesn't make sense. I mean, the SQLException, the interrupted exception, it doesn't make sense. They have been, of course, implemented throughout the language at the very beginning, where we didn't have the experience of using everything in the language. And they stay like that because of backwards compatibility. But, again, that doesn't mean they are good examples. Let's go a little bit further. I want to show you some real code from the Java security APIs from the JDK. This is code from the last version, from Java 23. Okay, what's wrong with it? Nothing wrong with it. I mean, from a design point of view, would you write the code in a similar way?
It looks like it throws those strange exceptions.
Okay, it throws a strange exception, which happens to be a checked exception, which happens to be the same as first point, which is a very good observation, actually. But the design itself has, I mean, it throws that exception from a different reason, which is, again, a design flow. This SHA 256 is a string there. What does that mean? You can misspell it. You can put whatever you want there. No. You can put ABCD. It's ABCD a hashing algorithm? No. You have a certain number of hashing algorithms that exist, but you can add there whatever you want as a parameter, which shouldn't be the case. And then what happens if you add here a value that doesn't correspond with any of the accepted values? It throws a no such algorithm exception, which happens also to be a checked exception, because why not? Why shouldn't I add more verbosity to my application? No, why shouldn't I have 5 lines of code instead of only 1? Why was it designed like that? Because the Java security itself has a way of working in which it allows some security providers to be added in the class path, which might come with different algorithms. So the problem they tried at the time of designing this API to solve was, how do we allow a third party add implementations to our API, but still be using the same API? So you see, I myself can implement my own hashing algorithm and name it whatever I want. And then I can add it, I can implement it as a security provider, add it in the class path, and then use the name here, and it will work And that's how, using classes from the JDK, I can use my own hashing algorithm. Anyway, never do that, okay? But this is the problem it solves, if you want to do that. And that's the case, this is message digest is for hashing, but that's the case for anything, public keys, private keys, I don't know, encryption algorithms, MAC algorithms, everything in the security part. It is designed over the same structure, same way. Can you give me an idea on how would I solve this? Say I would be able to change the JDK and change this design such that I fulfill the same requirements, but in a way that it's a little bit more clean. What would you do? And it would not really be a way to solve it. It would be a way to solve it only if you know already all the values. And in a factory which actually leads us to an interface. Exactly, that's how you solve it. You use an interface. Factory is it's a good answer, because when you said factory, you actually refer to the interface that factory method returns, okay? So the interface is actually the most deep answer to this question. You would have need an interface, and then whoever wants to design their own hashing algorithm would implement that interface. You make this string a parameter of that specific interface, and automatically then you allow any instance that implements that contract. That should have been the solution. This is a bad solution. The other one is what we would like to achieve. Because otherwise, you don't, first of all, don't know which are your options. Now, what is the problem with this, actually? One of them is you don't know your options. What can I put here? I have no idea. If I don't look into a documentation, or if I don't know precisely exactly what all my dependencies I've added to the class path support as algorithms. I have to look somewhere else to know exactly what I can put in here. No? And then, of course, we have already said from the very beginning, the predisposal to misusage. We started with that. Another wrong thing with Java. Did you know you can consider avoiding completely using generic types for whatever class declares generic types? In my case, is the bare minimum list here, where you can see this is a code that compiles, both lines compile with Java 23. You can declare a list, which is the interface, the contract. It declares a generic type, but you can avoid using the generic type. Same you can do with any of its implementation. Same you can do with any class that you write yourself. And there is a reason why we are using these generic types now, because it's a best practice. So why does the language still allow you writing types without the generics if this is decided as being a best practice? First of all, it's for backwards compatibility, because unfortunately generic types weren't there in the language from the very beginning of the language. I think they were introduced somewhere in Java 4 or 5. Yeah, I don't remember, I don't recall precisely, it was a long time ago. But it wasn't from the very beginning. So, and it's one rule of thumb that you should know about Java. They always try to keep backwards compatibility as close to 100% as possible. And once you don't have generics, you should be able to continue using that code without generics, because you didn't have them from the very beginning. Otherwise, it's not backwards compatible. However, I think that was Java 4, and now we are at Java 23. So maybe that backwards compatibility should be broken at some point. And I do think, but I think that will be the next subject, because it's another one about generics, is because now these are only valuable up to compile time. Do you know that? You know that generics in Java now, they are only essential up to the compilation. They don't exist after the compilation. So regardless, these three definitions here, you see them, okay? They are different before the compile time. after the compile time, when bytecode is created, all three lists are identical. You knew that, no? Because what are generics in Java? Those generics that have been long time ago introduced in the language. They are a flavor to somehow allow us avoid class cast exceptions. It's a way in which the developer is able to say, this is a list of only integers. Please don't add in the list other kind of objects. If you try to add them, it will fail. But then after it compiles, the instance just becomes, the attributes, the generic attributes just become objects. And this is a problem that will be changed with a JIP that's coming soon, 401, which is not unauthorized. It has been already authorized. It will be part of one of the future versions of Java. I added the link there for you to study further, and I will tell you quickly what this is about and why do we want it in the language. After this will be implemented, generics will stay even after the compilation, which means that if you declare the list of integer, in the bytecode, once the compilation happens, the array list, considering we have array list, we have an array. An array list is backed by an array. That's why it's called array list. That array will not be of objects, will be of integers, because that's what you said in the declaration of the generic type before the compilation. That's not happening now. It will happen with this JIP. And the real purpose of this is the possibility of using primitives as part of the generics, which comes from the necessity of implementing algorithms that are a little bit faster by excluding the object headers and mechanisms that come with the objects themselves from collections of objects. So what will happen in the future, and when I say future, I mean near future. I cannot tell you it's the next version. I cannot tell you it's necessarily Java 24, but I think Java 24, Java 25, somewhere in the next year, we might be able to see this. You will have the possibility to create primitive classes. Those primitive classes are like objects, but they miss some of the weight that comes with an object itself. For example, the synchronization mechanisms will not affect them. Do you know that when you create an object in Java, there is some synchronization that mechanism that applies to your object even if you don't even need it, no? You don't need it because you don't use at all synchronization in your code, but you have it. This is against a very essential principle that tells you give your client only what your client needs. Why should I give them the possibility to synchronize if they don't need the possibility to synchronize? Okay? With this, the problem is that also the performance of the application is affected. How could you make faster, especially use cases where you use large number of values? By enhancing the language such that you can create objects without all the additional stuff around, which we call primitive objects because they will be very close to how primitive looks like and is treated by the JDK in Java, by the JVM in Java. And then making generic types go throughout after the compilation so that when you create a list of some primitive, either it's a primitive like int, float, double, or it's a primitive object that you have declared, the list will contain the real primitives because it doesn't really make sense you make primitive objects but then generic types don't allow them and they are still objects after the compilation, no? It will make nothing in that case. So this is what this will fortunately be one of the things that will get solved. Another thing that you might see in the language is that everything is by default mutable. And we do not like mutability. And that's why in many cases, with applications where developers really want to make things better, you will see that a lot of final words become boilerplate code, which you have to put there just to put there because you want to have immutability throughout, for example, the procedural implementation of a given algorithm in a method, which is good. I do advise you do that. To write an algorithm that is more maintainable, start by declaring everything local, final. And then the question is, why doesn't the language imply that from the beginning? Because it wasn't the case. No, because these principles we've learned throughout time, and when things started, it was not the case. Will this change in the near future? As far as I know, there were some discussions about changing this, but they are still concluding to no because of the backwards compatibility, of course. Okay. And then, of course, there were also discussions of adding flags in the JVM when you start them, so you can do that. But again, it's not something clear that this will happen or not in the near future. However, until it happens, it would be your responsibility, use final. Another one that I like very much. Did you know that synchronized cannot be used on contracts? At least starting with Java 17 cannot be used at all. Did you know that before you could have used it, but it didn't make anything? I mean, you could have declared a method synchronized in the interface and implement it as non-synchronized. Do you know why both of these are bad? That was even worse in the past, no? In the past, it was even worse, because you would have expected something to happen. I mean, you see the interface, you see the synchronized, but then that doesn't happen because the implementation is not synchronized. So it may not fulfill the contract. How is that? A language that allows you not fulfilling the contract. And they acknowledged that. But they couldn't do more. They just said, okay, from now on, you cannot use in the contract synchronized. Which it's better, maybe, but it's still now, you can declare a method in the interface which is not synchronized and implement it as synchronized. So you don't know from the contract if your method is or not synchronized. This is bad. Because the reason we use contracts, we use interfaces, is to decouple and to make the client, for the client of an implementation, invisible the implementation. So that's why we use factory methods. We use a factory method. You get something, you get an instance. You have no idea what implementation is that, but you use it because you are able to see it through the eyes of a contract. But your contract doesn't tell you something very essential about your implementation. That, for example, it may be synchronized. And if this is something you want to make as part of a multi-threaded architecture, this may be very important. I have discovered this myself trying to solve a bug that was like more than 10 years ago. But I still remember it. Please.
Quick question. Was this documented like in the release notes?
If it was in the release notes?
Was this in the release notes so the end users were aware of it?
That you cannot use synchronized or the... I didn't... Honestly, I have no idea. I hope so. I have so. But I mean, it should be. Everything that is implemented in the language usually is not only made visible through release notes, but today in Java we use streams and I know YouTube presentations and everything, and it's always a very, very big circus made out of any version where you can see and demonstrate everything that has been implemented. But again, this is not something that is new overall. The problem itself overall is there since the very beginning of the language. Okay? So it is not normal that you cannot know from an interface from the contract that your implementation is or not synchronized, whether way it is. And I was telling you that I've seen this myself, And I had my own problems with this, trying to figure out why something doesn't work, until I had to actually decompose a full library to figure out that this was actually the cause, the root cause of a problem that I had, and find a way to solve it. Okay? And, okay. And of course we have serialization, which is something that have always caused especially security problems with Java, and we do not use it anymore. Serialization is that mechanism that is provided by the JVM directly to be able to transform in an instance of object in a way, in a representation of bytes, such that you can send it or store it somewhere, and the other way around. It has a lot of problems, so don't use it. If you ever see it used anywhere in your old code base, for example, and if it's possible, think about ways in which you can change it, for example, with Jackson or other kinds of serialization mechanisms that are safer and better. I want to close it now because I want to have a chance to give you also the 3 books and of course to answer other questions in case they are. So let me draw a short list of conclusions. First of all, keep in mind that these are not really problems that we should consider problems, meaning they happen because, like us, developers who implemented that stuff learned throughout time what is good and what is bad. You do the same. Maybe 10 years from now on, someone will look at your code and say, what's this? What the heck is this? No? Who implemented this? Maybe it will be even yourself doing that. You'll take a look, who wrote this code? And then you git blame and something like that, and you see your name there. No, it happens. So we learned throughout time. It's not, we don't have to blame anyone, but we have to keep in mind that this happens. And with evolution, things that today are good might not be good tomorrow. And then, yeah, that was actually the second point. And we need, again, to be adaptive to continuous learning approach, because this is the only way in which we can figure out that what we have been used yesterday is no longer the best practice for tomorrow. But that's something I know you are already doing because you are here with us, and usually when people attend conferences and community events is because they want to learn, and I believe it's the best, it's a good thing that you do that, and I would say you should continue doing this. So, in case you want to follow me on social media, this is the way to do it. Usually I'm active on YouTube, X, and LinkedIn. And now I want you to scan this QR code. I give you only a couple of minutes, and during the couple of minutes, please also share with me any questions you have.